All right, guys, let's do some more review, okay? So, here we go. Number 9. Use the limit definition of a derivative to find f prime. Oh, you hate the limit definition of a derivative. But the great thing is because you know the power rule, you can always check your limit definition to see if you did all of your algebra right. So, let's just get into it. Okay, so f prime of x equals the limit as x as h. That would have been the alternate definition. As h approaches 0 of f of x plus h. So anywhere there's an x, we change it to x plus h. So x plus h squared plus 1 minus f of x, which is x squared plus 1 all over h. So since we haven't taken the limit yet, we have to rewrite the limit again, right? Until we take the limit, you have to write that you're taking the limit every time. So we are still taking the limit as h approaches 0 of x plus h squared, which is x squared plus 2xh plus h squared plus 1 minus x squared minus 1, because that negative sign distributes. So we're going to still take the limit as h approaches 0. Let's see. X squared cancels out, 1 cancels out, and we know we did it right because we get all of our terms have an h in them. If they do not all have an h in them, then you didn't do something right and you need to check your algebra, because this is supposed to happen, right? The h needs to get out of the denominator because we cannot have 0 in the denominator. So then we look at this and we see the h cancels out and that h squared just becomes h, and now we are still taking the limit as h approaches 0 of 2x plus h. Now we're going to evaluate this by direct substitution. So now we can take away the limit notation because we're done. Now we're done taking, like we are taking the limit. You know, it's like when you take a square root, you get rid of the square root. Okay, so this would be 2x plus 0, which is just 2x. So the limit as h approaches 0 of this thing is 2x. And if you look back, we know that it was 2x, right? So you were able to do this. All right, so let's take a look at another one. Okay. Let's erase all of this. My eraser is really tiny. Okay. And I can't seem to make it bigger. All right. Let's do the next one, which is use the alternate form of the limit definition of the derivative to find x prime of 3. Okay, so the alternate form of the derivative is one that we forget a lot, and so remember, it's the limit as x approaches a. Now we use this when we're trying to find f prime at a very specific point, and so actually we should write f prime of a equals the limit as x approaches a of f of x minus f of a all over x minus a. Okay, so let's just plug this in, right? Okay, so we have the limit as x approaches 3 of f of x, which is x squared minus 2x, minus f of a, which would be 3 squared minus 2 times 3, all over x minus 3. So then we have the limit as x approaches 3 of x squared minus 2x minus 9 plus 6 over x minus 3. That equals the limit as x approaches 3 of x squared minus 2x minus 3 over x minus 3. And then we start looking at this and going, well, we got to get rid of that x minus 3 in the denominator so we can factor it. So it's going to be the limit as x approaches 3 of x minus 3 and x plus 1, because that's going to get us a negative 3. It's going to multiply to negative 3, add to negative 2, right, x minus 3. And now these two cancel out, and we have the limit as x approaches 3 of x plus 1. And then by direct substitution, we can just plug that in, and this is when we can get rid of our limit notation. And so we plug this in, and we get 4. So the limit of this function at x equals 3 is 4. Now we can go back and check, and we can say, well, we know that the derivative of that would be 2x minus 2, and that would be 6 minus 2, which is 4. So you have the shortcut to check yourself, but it's still important that you understand the limit definition because I said so. So that's the best answer I have right now. I know that it's not perfect, but that is my answer. Okay, so let's erase all of this. Seriously, it's like the tiniest eraser on this thing. Okay. Next one. It's if y equals all of this, then we find the second derivative. Okay, so let's find the first derivative, and I would write this as x to the negative 2 plus I'm going to write 1/2 instead of writing 1/2 x to the negative 1. This is just so much easier to do than quotient because, again, this isn't really a quotient rule thing because we don't have a function over a function. We just have 1 over a function, a constant over a function. Okay, so let's take the derivative of this, negative 2x to the negative 3 plus, actually minus 1/2 x to the negative 2. And then, so this is y prime. It's really important for us to define what that is. It's not y, so you can't just put equals. You got to put y prime equals so that you know that you took a derivative. Now we're going to do y double prime, which is 6x to the negative 4 plus 2 times 1/2 x to the negative 3, and the 2 times 1/2 cancels out. So y double prime equals 6 x to the negative 4 plus x to the negative 3. And let's check. Yep, we're good. That's what we needed to get to. Okay, last one on this page. So if that equals that, we got to find dy dx. Now remember, look at this. Can we get y by itself? No, not really. It would be really ugly if we even could. So because we can't get y by itself, we're going to use implicit differentiation. Yeah, I mean, I guess we could, like, do factoring. Yeah. I don't think I want to do that. I think we're just going to implicitly differentiate. Okay, so since we're doing, okay, and this is where this related rate stuff comes in. So we're doing dy dx, which means we're looking for the rate of change of y with respect to x. Meaning, as x changes, how fast does y change, okay? So x is our independent variable. X is the variable that we are taking the direct derivative of, which means it does not need a hook-on factor, okay? Because it's not a function of another term, okay? So for the x squared, we just get out 2x. Now here, we have to remember that this is a product. So we're going to have the derivative of the first times the second. I'm going to give myself some parentheses so I remember. The derivative of x times y plus the derivative of y times x plus 2y times the derivative of y, and the derivative of 5 is 0. And so then we have 2x minus y prime x plus 2y prime equals 0. We get everything that does not have a y prime on the other side. So that leaves us negative y prime x plus 2y prime y prime equals negative 2x plus y. And then we take our y prime out. So we take our y prime out, and we have 2y minus x still inside. We divide by 2y minus x and 2y minus x, and there you go. Y prime equals this.